and let us talk about modeling in Power BI. So maybe under modeling, we can talk about, I think the main thing here is the star schema. The star schema. And then the second thing is basically relationships in Power BI. So under relationships, we are basically going to discuss cardinality. I think here we can also talk about directionality, and yeah, challenges in relationships, and how to solve them, and solutions maybe. And then I think we can also talk about a bit about data cleaning in Power BI, data cleaning, or maybe a little bit of formatting on Power BI. So these are the at least these are the three main things that I would like us to talk about, and then we can call it a day. I believe for a night. I believe this week there hasn't been a lot of content, but basically these things we are learning about this week are also they're not so easy to understand. So I just hope by trying my best to explain these, at least if you don't understand everything, you'll be able to understand something. Okay, so the first thing that we'll talk about here under modeling is basically the star schema. So first of all, uh, we are talking about modeling. So models are basically like structures or tables that are in a database. So when you talk about the star schema, we are basically referring to a modeling technique. So in short, you can say it's a modeling technique um, that is used in maybe Power BI to organize data into, you can say, we can have like a central fact table surrounded by dimension tables to resemble a star. Okay, modeling technique. I think it's a modeling technique that is used even in data warehouses. So you can say used in a data warehouse or BI. BI basically means business intelligence. I think from the previous session, I asked you guys to go and find out what BI means in Power BI. So BI basically means business intelligence. So that is Power Business Intelligence. Okay. So when Power BI was first developed, it was basically used in businesses, basically for analysis and such kind of things. So it's a modeling technique used in data warehouse and BI to organize data, uh, into, we can say, a central. There's what we call a facts table, and this fact table is surrounded by dimensions tables to resemble a star, like that. So that is where we get the name star schema. So we have like one central table that we call a fact table, And then this table has other tables surrounding it. And then these tables surrounding the fact table are what we refer to as the dimension tables. So, of course, when you talk about the star schema, we have to be able to understand what a fact table is, and also we have to understand what dimensions tables are. So the fact table, um, we can say it's the central table, and then it's majorly made up of foreign keys that connects to the dimension tables. Yeah. So remember, when you talk about connecting tables, then keys play a big or a major role. So when you talk about keys, I'm basically referring to the primary keys, the foreign keys, and all those other keys. Primary keys are the unique identifiers of rows, and then we have uh, um, we have foreign keys that are basically used to connect two or more tables. So dimension tables, um, um, they mostly contain descriptive attributes. So for example, if we are referring to, let's say, sales data, we can have like product name, dates, customer details, but they're basically used for filtering and grouping data, right? Filtering and grouping data. So we have the fact table, which is like, we can say a fact table is like the main table, the central table, and then this central table has the ability to be able to connect to all the other tables that is around it. Okay, so that is why the fact table will mostly be made up of foreign keys, or at least keys that you can use to connect to other tables, right? So just like that, the fact table is at the center, connected to multiple dimension tables via relationships. And then dimensions tables are connected to each other directly, keeping the model simple. So why do we need this star schema? Why don't we just connect tables the way we want? Why must we have a fact table and then we have dimensions table connecting to the fact table? So you can refer to these as maybe you can say advantages, or I think advantages is a good word. Advantages. Advantages. Advantages of this star schema, or at least you can say, why do we need it so much? Why was it developed? Why is it a technology that has been brought into our attention? So star schema basically it simplifies queries by reducing the number of joins. Okay, so simplifies queries by reducing number of joins. You can imagine if you have a database of maybe, I don't know, like 15 or 20 tables, and then they are connected randomly. So in that case, um, um, there's some sort of complexity that has been introduced. And um, basically, if you are to write queries that involve joins, then it can be a little bit complex. But in this case, if you have like a table, a database made up of so many tables like that, you can have multiple star schemas. So you can have like a group of 5 tables that are interconnected or interlinked, so such that they have like a fact table, and then we have like some other 4 dimensions tables around it. Then you have some other star schema somewhere. This way, you are able to write queries because you are basically dealing with few tables. And then the fact that you have one central fact table makes it be able for you to link these tables, because basically all these dimensions tables are linked to one fact table, right? Another advantage or a reason why we need this is you can also say that it improves query performance, right? Improves query performance. Improves query performance. So how does it improve query performance? I think some weeks back we learned about normalization. So normalization, where you kind of like break a table into the table into like I think the first one is first normal form, second normal form, like that, like that, like that. So instead of doing all these, going through all these steps from first normal form, second, like that, you can just use a star schema, and uh, this one denormalizes the structure of your table, all right? Um, I think another advantage that we can add here is I think you can say it makes it easy for users to understand the model, right? Um, if you have relationships, it's easier for you and other people who will be interacting with this database to understand the structure of your tables and all that, right? Because basically you are grouping tables, you're putting tables into different groups based on the relationships. And then now a person can at least tell that these tables are related like this, like this, like this, and all that. So that is that on star schema. Basically, these are the main things you need to understand. You need to understand that a star schema is basically a modeling technique uh, that is made up of one central table, which we call a fact table. And then this central table has other tables surrounding it, which are referred to as dimension tables. So these tables, they surround a fact table based on the relationship. All right. If you have a table for maybe let's say product orders and they are not related to product orders, and maybe um, suppliers is probably related to products because suppliers will supply the products. What can you say? The products and shipping, those ones are somehow related. You have a product table and some other table that are not related. Of course, they cannot form a star schema because there is nothing relating or bringing those tables together, right? And then, of course, we also have some few example advantages of star schema. It doesn't mean there are only three. They can be more than three, but at least these are the ones that I can that come into mind. Okay. Then another thing we need to understand here is relationships in Power BI. So basically, what are relationships? So relationships basically they define how tables are connected. Okay. So you can say relationships define how tables are connected. They basically enable data to be combined and analyzed across multiple tables. So when you're using the join statement, it means you are referring to more than one table. You're joining one table to another table. And for you to be able to join tables, there must be something linking these tables. That is what we refer to as relationship. So they define how tables are are connected. So the good thing about Power BI is that it automatically detects relationships. If, for example, you have column names and maybe data types that match, then it's able to automatically detect the kind of relationship. When I say Power BI is able to detect relationships, it means the kind of the data set you have on your Power BI interface is basically like a database or something that is made up of more than one table, right? Now, in relationships, we have to be able to understand these key things. We have cardinality, we have directionality. These two main things are what makes up the relationships in Power BI. So, relationships define how tables are connected. But what is cardinality? So cardinality tries to, we can say it describes the nature of relationship. Okay, we can say it describes the nature of relationships between tables, between tables. So basically, it describes the nature of relationships between two tables or more tables based on how rows in one table relate to rows in another table. We can also say that it determines how data is filtered or aggregated between two tables. But basically, cardinality tries to describe the nature of the relationship. Remember, relationships is how tables are connected. But then now, if you want to describe um, the connectedness of the nature of the relationship, then that is what we refer to as cardinality. Now, we have different types of cardinality. Um, the first one we have is we say 1 to 1, 1 to 1, or in bracket you can say 1:1, like this. So 1 to 1 basically means each row in one table corresponds to exactly one row in another table. Each row in one table corresponds exactly to another row in another table, right? So one row in one table, one row in another table, right? If it's maybe let's say a column made up of let's say the column is product ID, you can have product ID 1, so that ID 1 in the first table corresponds to ID 1 in another table, right? So for example, if you are linking, let's say maybe you have a table for maybe employee details, and then you have another table for employee contact information. So if you have that kind of a table, those kind of tables, then the first table which contains employee details will have like an employee ID. So let's say the first employee has an ID of maybe 2002, right? And then you have the second table which is the second table which is employee contact information. So contact information also will also need an employee ID. So in this case, this employee who has an ID of 2002 in the employee details table corresponds to is the same employee in the employee contact information table, right? So this is the first type of cardinality. The second one is one to many, or I think some people say 1 to n, or 1 to star like this. That also means many. Remember, select all in the SQL, so it's the same thing here. So it can be 1 to n or it can be one to star like this, right? They mean the same thing, and it basically means one to many. Okay, so in one to many, it means one row in the first table, one row in the first table relates to multiple rows, relates to multiple rows in another table. So a good example of one to many can be, let's say we have like products table, and then this products table is linked to, you can say maybe sales table, right? So if products table is linked to sales table, we have product ID in both tables. But then in the products table, we have an instance of just one product. If the product is banana, and let's say banana has an ID of 1, in the sales table, banana can be bought by many people. It can be sold to more than one person, right? So you have multiple instances of the banana product ID, in this case, banana, which has a product ID of 1. So we'll have multiple instances of ID 1 appearing in the sales table. That is one to many, right? Then after one to many, we have many to one. Now, many to one, I don't want to talk much about it because basically many to one is the opposite of one to many. So if you have a relationship of one to many, it can also be many to one. And it's based on how you want it to be, but basically many to one is the opposite of one to many. Like in this case, we're using an example of products and sales. So from product to sales table, that is one to many. But when it comes from sales table to products table, that is many to one, because we have many instances of product ID in the sales table. But when we bring it to the products table, we only have one instance of that product ID, right? The next and the final one is many to many, many to many, or you can say end to end or star to star. So one to one is one row in one table corresponding to one other row in another table. One to many is one row in one table corresponding to multiple rows in another table. Now, many to many basically will have multiple rows in both tables relating to each other, right? Multiple rows in both tables are relating to each other. An example can be, uh, let's say we have like a students table and courses table, right? Students and courses. So if you have students and courses, we can have a student taking multiple courses, right? Like for example, in this case, at Alexia, we have people who are doing like data science, data analytics, data engineering. So you have one student doing multiple courses. At the same time, you can have a course that has multiple students. Okay. So in this case, we can say like these tables are linked via maybe student course with something you need to understand about many to many relationships is because we have multiple rows connecting multiple rows in both of these tables, we introduce what we call a bridge table, right? So we will introduce a bridge table that will have uh, some sort of keys that are common in both tables. And then now these tables connect through the bridge table, right? So it's like if we have the example I've given where we have students table and courses and courses. So in this case, we can introduce a third table. Maybe we can call it student course bridge table or something. So this table is the one that is helping us connect these two tables, that is students and the courses. But now, most of the time you'll be advised to avoid many-to-many relationship because of the complexities and all that, right? But we look at it later. Now, we've talked about cardinality. I think maybe I can demonstrate it on Power BI. At least you can see the various types of relationships that we have so that we understand better. Now on Power BI here, I downloaded a data set from Cargo. It's an SQLite data set. So it's made up of, I don't know, I've forgotten how many tables it has, but it's quite huge, so it may take some time to load. So you'll bear with me. So this is the data set. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 tables. Okay. It has 11 tables. So let me just load it, load all of these tables. So at a glance, you can see we have like customer table. I think let's let it just load. We have customer table, geolocation, leads closed, leads qualified, order payments, order reviews, orders, products, sellers. What was the name of these? I'm forgetting the name. It's called olist.sqlite. Olist.sqlite. So you can download it on from Kaggle. If you go to Kaggle, you can just search Olist, and then you'll find an .sqlite data set. That's the one you can download, and then you unzip it, you extract it, and then you have all the tables there. It's huge. It was around, I don't know, like 15 or 45 MBs if I'm not wrong. So it might take a little bit of time. Okay, that was fast. I didn't expect it to load that fast, but good. So we can have a preview of the data sets here from the data pane here. We have all these tables. We have customer table, geolocation, leads, closed leads, qualified, order items, order payments, order reviews, orders, products, category, name, translation, products, and sellers. Now, since we're talking about modeling, let us forget about visualization first, and let's go to the model view. So when I click on the model view here, look at what we are seeing. Now we have all the tables um, in model view, and then we also have the relationships and how each and every table is connected or related to one another. So I think let me give them some spacing a little bit so that it's visible enough. So you can have these like these. Mm, this one should come here. Yes, like this. And then we also have these ones linked on this side. Geolocation is not linked to anything for now. Now, this is the model view of this data set, right? So we have like order review table here. We have orders, we have sellers table, order items. This is product category name. We have order payments, customers, products. We also have geolocation, leads closed and leads qualified. Now, we've mentioned about cardinality, which basically describes the nature of relationships between tables. Then we've mentioned some of the types of cardinalities. The first one was one-to-one. So we said one-to-one, basically we have each row in one table corresponding to one row in another. I don't know if you have a one-to-one relationship. Oh, yes, 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 yes. So let's look at orders table here and then customers table. Now look at this line here. These lines are what defines the relationships. These are the, or we can say these are the cardinalities. Now, if I hover over this line here, you can see customer ID highlighted on the table. So it means these tables connect through that particular column. All right, they connect through the customer ID. If you are to query this, you can, if you are to join them, you can say orders and then join on customer orders.customer ID equals to customers.customer ID. So this is the relationship. Now, if you look at orders here, you can see here is one. So we have one, and then it moves like this. And then on customers, also one. So it means this is a one-to-one relationship, right? Orders and customers have a one-to-one relationship. They're connected on the customer ID column. It means on the orders here, if you have a customer who has an ID of one, that customer has an ID of one in the customers table as well, right? And then we also have one to many. Now, one to many, if you look at the entire of the model view, it's like the most common relationship we are having here. For example, look at orders and order payments. Relationship there from orders to order payments, you can see here is one. And then on the order payments, it's star or asterisk, or I don't know what they call it. So it means from orders to order payments, it's one to many, right? It's one to many. If it's moving from order payments to orders, it's many to one. So one to many is the most common relationship. Look at orders and order items. It's also one to many. If we look at orders and order reviews, one to many. If we look at sellers and order items, it's also one to many. So one to many is the most common one. On this model view, I'm not seeing many to many. Remember, I mentioned that it's quite complex and people try to avoid it. You should also try as much as possible to avoid many to many relationships, right? Now, we started this session by talking about modeling in Power BI, and we talked about star schema, right? Where we mentioned that we can have like one fact table, central table, and then we have dimension tables connecting to it. Now, I believe you are able to see my screen very well. I want to ask you guys a question. From this model here, I can see we have some sort of star schema, though not all tables, but at least there's a presence of a star schema. Now I want to ask, out of all these tables, which one is the fact table? Based on the relationship and how the tables are interconnected, which one would you say is the fact table? Just the fact table, not the dimension tables, because I believe there are very many dimension tables. Maybe somebody can just tell us fact table and why you think it's the fact table. Okay, do I need to
So
do?
everyone in the comments is saying orders.
Oh, okay. People are speaking in the comments. Okay, sorry. Okay, so of course, orders is the fact table. Okay, it's the central table that is connecting to almost all the other tables. Look, orders is connecting to order review, to order payments, to customers, to sellers, to order items and all that, right? So orders is the fact table here, and then we have all these other ones connecting to it, like order reviews, order payments, customers, order items, sellers, and the dimension tables, right? So in this case also we have a star schema here. But then, of course, that doesn't mean that the dimension tables cannot connect to other tables. Okay. For example, in this case, we have order items connected to products, and then products is connected to product category, right? On this other side, uh, we just have these two tables that is one-to-one as one-to-one relationship, right? So I believe you've understood about the star schema and also cardinality. We've seen how the tables are connected. We've seen the one-to-one relationship, one-to-many. We've not seen many-to-many because people try to avoid it. And so that is what this person was also trying to do here. He was trying to avoid it to avoid complexities that comes with many-to-many. But if, for example, let's assume sellers and order items was many-to-many, then we would have a star here the way we have. And then this one also, instead of one, we'll also have a star there, right? Okay, now let's go back to our notes. So that is that on cardinality. The second thing we need to talk about under relationships is directionality. Now, cardinality describes the nature of the relationships. We've seen like one to many and all that. Now, directionality defines how you will filter or propagate between related tables, right? It basically defines how you filter, or you can say propagate, or maybe flow mm, between related tables, related between related tables, right? Now, we also have different types of directionality. Um, Types of directionality. We also have different types. So the first one, we have single single directionality or single direction. So in single direction, filters flows from one side of the relationship to the other, right? So it just moves to that direction from one side of the relationship to the other, right? And then we also have bidirectional. Bidirectional. Yes, I think that's the spell. So in bidirectional, filters flow in both directions, right? In both directions. Okay, now let's come back here. Now, directionality basically it defines how filters flow. between related tables. Let's take an example of orders table here and order reviews. Now, why did we say the relationship here is one to many and not many to one? Because of the direction of the flow of relationship, right? If you look at this line here, we have a small tiny arrow here. This arrow is moving from orders to order reviews. You can see the head of the arrow pointing order reviews. So this is a single direction. Okay. If you're asked about the directionality here, it's single direction and it moves from orders to order reviews, right? So you need to take note of the direction of the relationship. If it's from orders to order reviews, then that is the direction. You cannot change it to order reviews to orders, right? So basically, it means um, you cannot move from order reviews to orders. The direction has to be from orders to order reviews based on the directionality of these two of relationship of these two tables, right? Um, look at orders and order payments also. This one is also single direction and it moves from orders to order payments, right? However, let's look at orders and customers. Now, for orders and customers, it's bidirectional because if you look at the arrows here, we have one pointing to the orders and another one pointing to customers. So it's pointing on both directions, right? So the directionality of orders and customers is bidirectional, both sides. So it means you can move from orders to customers or from customers to orders. You can query from orders to customers. Or you can also query from customers to orders, right? Now, one thing about directionality is that most of the time, most of the time, one to many relationships will mostly be single direction. One to one relationships are mostly they are mostly bidirectional, right? So a one to one relationship, if you find a one to one relationship, there's high chances that the directionality is bidirectional. That is from both sides for both sides. But then if it's one to many, then the higher chances of directionality being single, right? Another thing is in star schema, most of the time you'll find single direction relationship or directionality, right? In star schema. Why is that? Because uh, most of the time you'll find that you are having one table, which is the central table, the fact table, connecting to very many other tables. And then what normally happens is you'll find that most of you'll find that in a star schema, the relationship is mostly between the tables is mostly one to many. So that is why in a star schema, directionality mostly will be single direction, right? Okay, I believe up to this point we understand cardinality. We know the types of cardinality. We can demonstrate and show them here, and we also understand directionality.
Sorry to interrupt. There is one question in the messages, and it
Mhm.
what determines the directionality? And then another one, can one customer place many orders or is it restricted to one? Yeah, because I was also curious. I was like, the relationship between orders and customers is one to one, but what if as a customer you place many orders? Yeah.
Okay, I didn't get the first question well.
The first question was what determines the directionality?
Oh, what determines the direction? I think relationship, the relationship that you have. For instance, um, one to one, most of the time you'll find that the directionality is bi-direction. Then one to many is mostly single direction. So in that case, I think the cardinality, the type of cardinality, if it then there are higher chances of it being bi-direction, and then if it's one to many, uh, you'll there are higher chances of it being single direction. And then other question you asked was, can customers?
Um, the other question was, um, uh, can one customer place many orders or is it restricted to one? Then I was curious because I was like, the relationship between orders and customers is 1:1. So what if a customer places many orders? I hope I'm not
Oh
confusing.
yeah, yeah, yeah. I see, I see. Okay, yeah, yeah, yeah. I see what you're referring to. Okay. Well, this is the relationship I found in these data sets, but other items, products. Mm, yeah, I think you might be right. Maybe one to one may not make sense in this case. A customer can have more than one. It can make multiple orders. Other items.
Okay, but maybe it's something they're only allowed to order once because there's some things you can only order once.
Mm, I think what this person has done here, because I'm seeing there's an order items table here. No, that will not make sense. I don't think that is going to make sense. I wanted to say that maybe no, that will not make sense. Let me not say it. Um, okay, but okay, that's a very nice observation. That's a very nice observation. Any other question?
Um, there are no other questions in the comments, but maybe if someone has a question, they can ask.
Yeah.
Also, I have dropped the link to the feedback form in the comments. Please fill it and since fill the score as Kenya 1, 2, and 4. Just tick Kenya 1, 2, and 4. The link is in the comments. It's in the chat. I think you can continue.
Okay. So I think we can go to challenges that you may face in relationships and how you can resolve or you can find solutions to them. Um, I'm not going to mention all of them, but at least I'm going to mention the ones that might be common and that at least I'm aware of. So that can give you uh, opportunity to also go and do some research. So the first challenge, there's something we call circular dependencies. So a circular dependency is when you create, you can say when you create relationships that form a loop. Okay, a relationship that form a loop. For example, let's say if you have like table A, and then table A is connected to table B, table B is connected to table C, and then table C is connected to table A. So see, this is like a circle or a loop. So it moves from A, B, C back to A, then B, C, like that, like that. So it goes in a loop. So this kind of relationship can be can be problematic because okay, in this case, it's not it's not in a form we want it to be in. Like in this case, schema, there's star schema, right? So it means establishing a relationship between these tables can somewhat be problematic, a little bit problematic. So this is one of the most common challenges you may face in relationship. Now, how do you resolve this? How do you resolve circular dependency? So the most common, straightforward way is basically to turn this into a star schema, right? So you can turn this into a star schema. So it means if these tables are so much related, then you can create maybe a bridge table, and then that bridge table will be the fact table. So you can just create another table that has capability of connecting to all these other tables. So in this case, there are three tables, A, B, and C, and then we connect all these tables into that central table, right? So that we can avoid the looping. Okay. So that is one of the problems you may face. Another one can be, oops, let me just connect my laptop very first. Okay. Number two, um, sometimes when you have like missing data or invalid keys. So if you have missing or invalid keys, basically it means uh, your data is incomplete. Okay. Data. So if your data is incomplete, then um, okay, this thing is disturbing a little bit. Okay, I think it's okay now. So if you have missing or invalid keys, this means your data is incomplete. And we all know that incomplete data can result to it can result to errors or something of that sort. So basically, in this case, data cleaning is always advised. So it means thoroughly check and clean your data before you do anything, before visualization, before checking on the models and all those other things. You need to clean data. That is why when you are learning data analytics, you are introduced to Excel first. And what did we do with Excel? We were basically cleaning data. After cleaning, that is when we started some small visualizations. So data cleaning is a very important step in data analytics or data science. Remember, you don't just visualize data. We visualize data so that we can get insights. So if you have missing values or incomplete data, then you'll not be able to get accurate results. So data cleaning is important. Another one can be, let's say, you can say like incorrect cardinality, right? You can say incorrect cardinality. So if you assign, for example, wrong cardinalities, if you assign wrong cardinality. So for example, like where we are supposed to have like one to many, you put maybe one to one. This can lead to incorrect filtering. All right. So incorrect filtering means that relationship is not a valid relationship, and therefore it means even when you'll be querying or doing something with your data, there are higher chances that you'll not be able to get the correct result. So for incorrect cardinality, the solution is you need to be able to verify unique values in your keys, right? So the columns where we have the keys, you need to be able to verify their values. This is mostly done in the Power Query editor, or in this case for Power BI. We're going to look at it in a bit. So I've mentioned circular dependency, missing data, incorrect cardinality. What other challenge can I think of? Um, Sometimes, let's say you have like ambiguity in your relationships. Ambiguous. How do you spell ambiguous? Ambiguous relationships. Uh, Basically, this means Power BI cannot determine which relationships to use because you probably have like multiple paths existing between your tables, right? That confuses even Power BI. So if Power BI is not able to detect your relationships automatically, it means there's a problem. I think the best thing you're supposed to do is always ensure that your models, when you load your data into Power BI, at least Power BI is able to automatically detect the relationships. But then, if it reaches a point where you have to like set them manually, then manual setting uh, increases the probability of errors, right? So the solution to ambiguous relationships is basically you can always try to use single relationships per table pair. And also another thing is you need to deactivate relationships that are not useful, right? You don't need to create relationships that are not useful, and if they exist or relationships that are not being used, unused relationships, then you need to deactivate them. I think these are the challenges I can think of for now. If there are others, I don't know, you may share with us. I think you may share with us. But basically, this is what I wanted us to learn on modeling in relationships. If there's something I've missed out, feel free to add. But the main things, I believe these things that we've tackled here should be able to help us understand this week's train very well. Now, the last thing I want us to talk about here, and then we can finish this session, is data cleaning, uh, specifically in Power BI. Of course, we know data cleaning is basically when we prepare raw data for analysis by removing errors, right? Preparing raw data for analysis by removing errors. We learned how to clean our data in what is it called? Excel or Google Sheets. But then we need to also be able to clean our data in Power BI because sometimes you may not have the time to load data into Google Sheet or Excel and then do the cleaning and then bring it to Power BI for visualization. So there's some key things you need to do here. So for example, basically data cleaning involves removing errors, right? We can sometimes have like we can have like duplicate rows. You can have your data can be having missing values. You can have incorrect data types. Um, uh, Another thing can be, let's say, like you have unnecessary rows or columns. You need to be able to get rid of these things because they're basically things that justify your data. So the first one, like removing duplicates. Okay, this basically involves eliminating rows that appear more than once. How do we remove duplicates in Power BI? So I think the first one you can say the first activity here can be removing duplicates. How do we remove duplicates in Power BI? Now, there's a special tool in Power BI that is good, or at least that is used in for data cleaning and I think formatting and all that. We call it Power Query Editor, right? Now, how do we get to the Power Query Editor? On the home ribbon here, we have this thing here, transform data, drop down. So transform data, and then you have data source settings. So when you just click on transform data, we have this window that pops up. Up here, you can see untitled and then Power Query Editor. Now let it load a little bit. Yes, so it has loaded. Now this is the Power Query Editor. Now on the Power Query Editor, on this side, we have the various tables. So for example, the first one it has loaded here is customers. You can click on geolocation and then it loads the data. So you are basically able to view your data from the Power Query Editor like this. It displays your data in tabular form. We have the column headers here and all that. Okay, now how do we remove duplicates from the Power Query Editor? So when you come to the Power Query Editor, like in this case, the default ribbon here is home. So on this home tab here, we have remove rows. Where is it? Remove rows. Yes, this one here. So remove rows. We have that. What is this thing called? Mm, Drop down. Yes, this little arrow going down. So we have the drop down. So when you click on it like that, we have all these. Options. The first one here is remove top row, remove bottom rows, remove alternative rows, remove duplicate rows, remove blank rows, like that. So if you have some rows that are missing data, then you can click on remove blank rows, remove errors. So Power BI is able to also detect errors, and then when you click on remove errors, then it should basically just get rid of errors. We also have remove duplicates. So if at all the data contain duplicates, then you click on remove duplicates. Like in this case, if I click on this, it's trying to search for duplicates. So when you remove duplicates, take a look at this right pane here. So we have these applied steps. So Power Query Editor is able to detect everything you do on the data set in this case here, and then it records. So for example, you have here removed duplicates. So anything you do is recorded on this section on the right side here, right? If I go to the next table, for example, these leads closed and all that, everything I do on this table will be recorded here. Currently, I just navigated to this table, so that's why here it indicates navigation, right? If on this table also I decide to remove duplicates, it will record removed duplicates, right? I can go back to this top one like that, right? So that is one way of course, cleaning your data by removing duplicates. You can also correct data types. You can correct the data types that are in your table. So for example, yes, this column here on the leads closed, we have one date. So when you click on the column name here, Mm, just a minute. On the column name here, we have we have these letters that appear. Then we also, I want the one with letters and numbers. Yes. So for example, on the order items table here, we have, for example, price, and then it writes 1, 2. So it means these numbers. And then shipping limit date. Okay, it's recording date as text in this case. So we have ABC. Seller ID is uh, is uh, is text. So how do we ensure we have the correct data type? So mm, that one. Okay, I don't understand why it's not bringing it, but basically, let me try with another table and see. Okay, it's not bringing. Mm, oh, we text data type. Okay, I don't understand why it's not detecting the data types in this case, but basically it's supposed to be able to detect the data type unless I'm doing something wrong. Um, so it's supposed to be able to detect data type and then it's record because we should be able to change the data type. For example, if this column was maybe string and then it's supposed to be numbers, then you're supposed to be able to change it. I don't know why it's not showing me that option now. Hmm. I don't know. I don't think if it's here, you know, that is when you want to add a column. Okay, this one has refused to show me. Let me close and then reopen it again. Hmm. Okay, let it load the changes.
In the meantime, someone is asking if you can undo the changes you make with Power Query.
If you can,
Undo the changes you make with Power Query.
if you can undo the changes, let's see. I believe we should be able to undo. There's always that, what is it called? There's an arrow somewhere that you're supposed to use. I don't know why this thing is not detecting my data types because I should be able to change. Probably I'm doing something wrong. Um, let me see what is the problem.
Hmm?
Okay, I can't see what the problem is. I don't understand why. You said somebody was asking how you can undo the changes. So let's say you want to delete duplicates in this particular in the rows, so remove rows, and then let's say in this case we remove duplicates, and then we want to reset it back to what it was. So you see on the applied steps here where it's recording the changes, you just come and click on this X here. So when you click on this, it takes you back to the previous instance of the data that you are having previously before you, of course, did whatever it is you wanted to do. Um, I wanted to show you guys how you are supposed to change data type, but I don't know why this thing is not showing. Oh yeah, okay. Here it is. So there's a table that had some wrong data type. For example, if you want to change this geolocation latitude, which is recorded as, I don't know, is it recorded as decimal, and then you want to change it to whole number, you right click on the column name and then change type. So currently it's decimal number. You can see decimal number has been fixed here. So when you click on whole number, then it I place current, yes. Yes, so you see it changes all these to whole numbers. Now, how do you know that data type is whole number and another one is decimal? Now, you use these upper sections to be able to detect the type of data that is in a particular column. So, for example, if it's 1.2, then that is decimal. But if it's a whole number, then it will record as one with the two up and then three down like this. So basically it means the location zip code prefix here is a decimal. If you right click and then you go to change data type,
Nilikulima mchizi mchore stone orile coconut le yakwa.
somebody asking a question. Okay.
Lebo,
So for
Lebo,
example,
please. I'm sorry. Lebo, please mute your audio.
okay,
Lebo gang, please.
okay. So for example, in this case, the geolocation zip code, the type is decimal. You can see up here is recorded 1.2, but we can of course change it to whole number. And then when we change it to whole number, you see this one now changes to 1, 2, and 3 instead of 1.2. So if it has a 1 and then dot, basically point means it's a decimal number, right? Geolocation state, this is text. You can see ABC written there, but basically that is that. So you can change data type by just right clicking, but oh, this one cannot change. Oh God. But then there's also other options of, let me just move this. There's an option where when you click on the column name like this, then it's supposed to display here the type of data. There's some drop down that's supposed to appear up here. I don't know why it's not appearing uh, for now, but that is also another way of uh, of changing the type of data. Oh, I see. There's another one here. There's another one up here. So when I click on column, take note of this part. When I click on a column, yes, data type, decimal number. That is also a decimal number. That's also a decimal number. This is a text. decimal number. Let's see if we can change it from here. Whole number. Oh yeah, it changes. Okay, there's also another one up here. I don't know if it depends on the version of Power BI you're using or what, because initially I had something on this side where I could change the data type. So that is how you can change into correct data type. What else can you do? Yes, sometimes you can split columns. So for example, this is shipping limit dates. So on the shipping limit dates here, it records the year, the month, the day, and then the time. So if we maybe wanted to split this column, we can right click on the column name and then split column. So you can split it by delimiter. So delimiter, basically things like if it's a comma, a dash. I don't know if they have space. Yeah, space. So let's split by space. Um, it's occurrence of the delimiter, and then okay. Yes. Now you see this column has been split into two. So we have shipping limit date one and then shipping limit date two. So this one records the year, month, and date. This one records just time. That is hour, minutes, and seconds. So probably we can rename this column as maybe shipping time or something. Shipping time like this. And then we can say the shipping dates like that. So we basically transform these columns. We split the what was it called? I don't know, shipping something something column. We split it into year and time. And now instead of one compact column, we have two. So you can split columns the way you want them to. Yeah, I think that is that. What other thing can you do? Um, okay, I think those are the main things I can think of for now. But basically, I don't think cleaning is too complicated. The main things you encounter is maybe null values. If you want to split columns, you want to deal with duplicate rows and all that. Anybody with any question. And by the way, if you're working on the Power Query editor and you are done, you want to save your changes, you have to click close and apply here. On the left side here, you have to click close and apply. So when you click close and apply, it will apply all the changes that you have made, and basically that means that will change your data a little bit. Sometimes also when you click on the what is it, the close icon for Power Query Editor, it will prompt you if you want to save changes or if you don't. So in one way or another, you'll have to decide. So currently, I think these things, the data set is so big with so many rows, that's why it's taking time to load. Okay, so those things have been changed. What table was that we split columns? I want to confirm. I can't remember the table name. What was it, geolocation? Okay, I can't remember that column name. I can't remember that the name of that table. But yeah, I think that is that on today's session. I would wish to stop there unless somebody is having a question. Anybody with a question?